Okay, well, hello and welcome. This is Stats 102A, and I believe many of you have already met our TA, Andrew. And so, and I believe Andrew went over the syllabus with you. So that's great. And well, anyway, while you guys are here, I will just make an appeal that, and thank you to everybody to all of you for coming, first of all. And thank you to everybody who has turned on their cameras. That's very much appreciated. And if anybody else who is willing to turn on their camera, that is also much appreciated. You know, it's taking a class online is it's not the same as teaching in person, but at least when I get to see your faces, it's nicer. And just the fact seeing you there and like you nod your head, that that like speaks to my soul, so that I appreciate that. And it's a little bit sad to say, but I've had a lot of students this past year, and I honestly have no idea what they look like because they've only appeared as a name inside of a box. So that's what we have. Okay, we have a question in the chat that says, has anyone made a group me yet? And I'm actually going to request that nobody makes a group me, and I'm going to request that you use the Campuswire forum. So you should have received an email invitation to Campuswire. There's also a link on CCLE. So here is our CCLE page, and here is the link to the Campuswire forum. You should be able to join there. If you need, I think, let me go ahead and just add this. The join code is 0962 if you need to, if you need that. But I think I tried emailing you invites to join. And so anyway, post your questions on Campuswire. I'll be posting a lot of announcements here. And Campuswire, you'll get participation points for doing stuff on Campuswire, and it's all covered in the syllabus. This is really the only place where you can get like extra credit if you actively participate on Campuswire. You can earn an extra credit point, and there's a few kind of just tips on how to use Campuswire, and you can kind of check your grade and stuff like that there. So anyway. Yeah, that would be my preference. Andrew and myself will be there, but basically I want to encourage you to answer each other's questions. There's actually, you learn stuff when you answer each other's questions, right? Like in order to write an answer, you have to kind of reach a point of where you feel confident in your answer, and that's going to make you think about the answer. And you know what, if you answer something and it turns out to be wrong, that's okay. Somebody can just say, oh, you know what, that's actually not how it goes. And that's how we learn. You don't have to be embarrassed that you provided an incorrect answer. So don't do that. Okay, so don't feel bad about, giving an answer and it turns out to be incorrect. Somebody has entered a message in a foreign language in the chat, and I'm gonna just ask that that will keep that we keep it in English in the chat for everybody. Okay. So anyway, that's okay. And so anyway, do that on Campuswire. Okay, let's go ahead and get started here. Oh yes, welcome. There we go. I hope you guys all had like 1 week between finals week and this week, and I hope that week was restful. It was very restful for me. I bought passes to Magic Mountain, and like I took my family to Magic. We went there like 3 times this past week, and I hadn't been there in like probably a decade. It was a lot of fun. I mean, I got a little kid, so we hung out in Bugs. Okay, you guys don't need to. Anyway, all right. So oh yeah, so my name is Miles Chen. I don't know if I said that already, but that's who I am. And feel free to call me Miles. Okay, that's totally fine. Okay, if that feels weird, you can call me Professor Chen. You can call me Dr. Chen as well. I don't like being called just Chen by itself. Like you might say like, hi Chen, that feels weird to me. So, and then, if you're gonna write me a message, use some kind of address rather than just like, hello there. Okay, a few things. Read the syllabus if you haven't already read the syllabus, but make sure you read the syllabus. Make sure you check Campuswire frequently. And on Campuswire, make sure your name on Campuswire matches your name on CCLE, okay? Because if you want your points from Campuswire to come over to CCLE, I do it manually. I just kind of look at your name over here, and I look at your name over here, and I make sure that it matches. And so if you're using some kind of initials, or if your name's not there, I might not be able to figure it out. Okay. You guys are here live, so this doesn't apply to you, but if you didn't attend live and you're watching the video, make sure you watch the video, okay? So make sure you watch the video if you don't attend live, okay? And then these are please things. Come to office hours if you got questions. Office hours will be you'll get your answers faster. And if you're here live, please turn on your camera. Those are pleases, not requirements. Okay. All right. This is how I'm going to take attendance regarding the class. Okay. So I don't do live attendance because I understand people live in different time zones and things like that. So the way I'm going to kind of make sure people are here and have at least watched the lecture, if they watch the video, is I'm going to do something called a lecture view quiz. All right. And so you can see on CCLE, the first one here, week 1 Monday lecture viewing quiz. That's what we'll have. And preview quiz, I guess. Let's see if I switch my role to a student. Okay, so this is what you have, the lecture viewing quiz. You can click attempt quiz now, and this is what the quiz looks like. Okay, it's just A, B, C, D, E. There's no context to any of these questions. Okay, and basically I'm going to give you the answer to the lecture viewing quiz just by kind of talking. And so you have to at least be listening to me talk. You're not going to find it in the lecture notes. You're not going to be somewhere else. I suppose, I don't know. Okay, so anyway, just for an example, the very first quiz answer is the letter B. The letter B as in bear. Okay, B as in bear, B as in Bruin. You'll want to jot this down somewhere. Okay, and then at the and I'll give you the answers to the other 2 questions between now and 5:50, and you'll just jot those down. And then at the end of class, just take the quiz and click finish attempt, and you should get 100%. Right? It should be very easy, and you should be able to get. It should be an easy way to earn points without without too much effort. But you get points just for watching the lecture. Okay. All right. So we have and so you have to take the quiz. You have to take the quiz before the next class. Okay. So today's quiz you have to take before Wednesday at 4 o'clock. So you have to watch the video, or you have to take the quiz between now and Wednesday. And then Wednesday, you have to take it before following Monday, okay? Although next Monday, we have a holiday where the university is observing Juneteenth. So I'll extend, so Wednesday's quiz will be open until the following Wednesday. So you have like 7 days to do it. But in general, on Monday, you'll have like a little under 48 hours. Okay, people are asking questions in the chat. Let me see. If we do them during class and miss an answer, is it okay for one again at the end? Well, if you miss a thing, you can ask in the chat. So I'm okay with you asking. You can ask me in the chat for the answer. But it is like a quiz, so it's not it would be considered cheating. Just like if you shared answers to any other quiz, that would be academic dishonesty and cheating. So don't, like if your friend didn't come to class and didn't watch the lecture, don't be like, oh, the answers are ABC. That's, just like sharing answers to any other quiz, that's not good. Okay. Will the test always be A, B, C, D, E? Yeah, that will be it. There's no academic questions. There's no, like, you don't have to understand anything, right? Hopefully my lecture, you'll understand what I'm talking about. But even if you don't understand anything in the lecture, if you just hear like, oh, the answer is A, you'll be able to answer these questions. Okay. Is there a time limit? The time limit is before the next lecture. Okay. But it's not like you have 30 seconds to comply. So anyway, that you'll get the hang of it. Okay. Don't stress about this. All right. It's about as easy as it gets. All right. Okay. Campuswire, post your questions on Campuswire. You're more likely to get a faster response from classmates than from me. If you don't want your question to be public because it's something personal, then you can come to office hours. I can set up a basically the waiting room and we can talk privately. No problem there. You can also send me a DM on Campuswire, probably a little bit faster response that way. You can also send me emails, but I will admit I am very slow and bad at responding to emails. So that's that. Okay, let's go ahead and let's talk about what this class is all about. Well, I don't know. Are there any questions before I get started on content? Okay, well, thank you for that. Okay, and then if you don't want to turn on your camera, you can, and I say like, are there any questions or do you understand or things like that? You can, if you don't want to, if you have your camera on, you can just nod your head or shake your head, or you can give me a thumbs up on camera. But if you don't want to turn on your camera, the other thing you can do is you can use a reaction. And you can do something like, you can give me a thumbs up there. Yeah, exactly, right? Or, the cheers. Yeah, okay, so quiz number 1 is B. Yeah, so quiz number 1 question today is B. That is correct. That is correct. Okay, and I'll give you the answers to question number 2 and question number 3 later. Okay, all right, let's talk about what this class is. We've got a lot to cover. There will be some parts of the lecture where I'm going to just kind of skip through and you just have to kind of go through the lecture notes yourself. Okay. We've got a lot to cover in 100 minutes here. All right. So I would say this class is kind of all about foundations for data science. And that's really a lot of what the statistics major is about. And this idea of what is data science emerged several years ago, maybe 10 years ago by now. And Drew Conway said, the data science Venn diagram consists of these kind of three fields, right? You've got coding skills. He calls them hacking skills, but this is basically the ability to turn an idea into computer code, okay? You also have math and stats knowledge. So you need to kind of have a theoretical understanding of kind of these statistical concepts and mathematical concepts, okay? And then in order to be really of any use, you need to have an understanding of the field from where the data is coming from, right? So data science and statistics is one of those things where you can apply it to a whole bunch of different things, right? You can apply it to marketing, you can apply it to health research, you can apply it to social science research and environmental studies and pretty much anything. And so you need to be knowledgeable in whatever domain that you are going to be applying this in. And so we might call that domain knowledge or substantive expertise, whatever it is. And I would say the statistics major, the data theory major, or even if you're like minoring in statistics or something like that, will kind of give you exposure to at least these top 2 circles. There's too many things we can't cover substantive expertise for every single subject out there. So this is up to you and on your own. Okay, but we'll give you kind of math stats knowledge, and we'll give you this class will kind of cover a lot of the coding ideas, coding skills to kind of turn some of these ideas into code, okay? And so the overlap of that we can call machine learning, okay? This part is labeled the danger zone. So this is where you have like you are able to write code and you have some substantive expertise, but maybe you don't quite understand the theory. And so you might be applying certain ideas and concepts, dangerously in terms of, maybe the assumptions don't quite make sense and things like that. Okay. But anyway, you combine all of that with some knowledge, substantive expertise, and this is really important. And you can have real data science being done. Okay, there's probably been modifications and versions derived from this Venn diagram. I've seen Venn diagrams where like 7 circles are overlapping and things like that, but they're all really just kind of variations of this picture here. And so this class is going to kind of introduce you to this field of computational statistics and data science. And what the big aim of it is to develop your coding skills. You guys have already taken Stats 20. That's a requisite for this class. And some of you have had varying amounts of joy and pain and delight from that course. And this class hopefully will kind of, push you a little bit farther in terms of being able to write, things that are a little bit even more complicated in code. Now, and of course, anytime you start something for the first time, that's always the most uncomfortable. So Stats 20, if that was uncomfortable for you, it was, it could have been tough, right? If that was especially your first coding class. But, once you start understanding how kind of computers understand code, then, hopefully expanding on that is not going to be too hard, right? Thematically, this class, we can kind of divide into 2 sections, and it's going to split somewhere around week 3, week 4, where, the first half, we're going to be kind of developing your programming and coding skills some more. And then in the second half, we'll introduce some methods of computational statistics. And this will be a little bit more, mathy theory type stuff. It's not really, maybe, I wouldn't say theoretical. It's just maybe some conceptual ideas and a little bit less on focusing on programming stuff. Okay. Some of you have written messages, direct messages to me that, will take a little bit of a while for me to address. So I can address your questions at the end of class. I do have office hours. So lecture ends at 5:50 and I do have office hours after that. So just stick around and I'm happy to answer your private questions then. All right, so this is just a list of stuff we'll cover. This is all listed in the syllabus. Same with this. So, we'll just, you guys can read. So we'll do that. Okay. One thing I do like to say is I like to think of this class as a quote unquote coding 2 course, and that, as a UCLA student, in order to graduate, you have to take a course that fulfills your writing 2 requirement. Have you guys already taken that class, or are you guys pushing that off to do later or things like that? So, your writing 2 course, you probably end up having to write like an essay almost every single week, or like at least multiple essays during the thing. And I think it's good because it forces you to develop your writing skills, right? And so similarly, this class, you're going to have these homework assignments that, frankly, some of them are going to be lengthy in terms of the amount of code that you have to write. And the purpose of those assignments is for you to develop your coding skills. And that's going to be especially important, right? UCLA says, the ability to write is a very important skill for you to have in order, when you graduate. And I believe if you're going to be a statistician, data scientist, or working in this kind of industry, you need to be able to write code. And the best way to kind of develop your skills of writing code is to actually have, write the code itself, right? And so this is how I kind of like to think about that, okay? And so with that in mind, I do want to say a few things about academic integrity and plagiarism. And this is known to be just across all universities, even at UCLA within the statistics department, but just broadly speaking, across universities across the country and globally, really, there's a huge problem with academic integrity in coding-based courses, okay? And I think there's something unique, I don't know about unique, but just the fact that a lot of times, the solutions that you write for code, you can just kind of, you can find these answers online readily. And so, for the homework problems I give you, probably with a Google search or just even a Bing search, whatever search engine you want to use, you go on GitHub and things like that, you can probably find code that exists that will do exactly what you need it to do, okay? And in fact, this is a good thing that exists, that especially if you want to implement something complicated, there's probably a package out there that already does it. It's been verified and checked by many people, and it does these things. And to be honest, when you're working in industry and things like that, if your goal is to accomplish some kind of task, then yes, absolutely, you should go online and you should see if somebody has already done the task that you're trying to do, okay? And if there's a package that exists, then that means a lot of people have looked at that code, and this is going to be high quality code that you don't have to worry about like crashing and failing because you made some kind of mistake, okay? But this class is not industry. This class, the point of this class is that you learn, right? You learn to write code, you develop your skills of writing, and the goal is not to accomplish some kind of task, right? I'm going to give you some, in your first homework assignment, I think one of your things is like, do a prime factorization of some numbers, okay? I don't actually care if, like, it's not like it's a mystery, like I'm trying to figure out the prime factorizations of these numbers, right? But it's an exercise that forces you to kind of think of like, okay, how can I write this? How can I approach this problem? How can I write this thing? And the process of thinking through that kind of puzzle and that problem is going to help you to learn to write and improve your coding skills, right? And so I like to think of all of the assignments I give you as almost like exercise in terms of, going to the gym. And I think this is a concept that a lot of people understand, and yet somehow it doesn't translate over to academic and coding work as easily. And so I kind of want to draw this analogy and just really encourage you to kind of be honest in this way, right? So if you think of like going to the gym and like lifting weights, right? You're trying to lift weights to get stronger. And, there's often the saying, you say, no pain, no gain. And the idea there is that if you go to the gym to lift weights and you're lifting very light weights that gives you no, doesn't challenge you at all, right? You barely break a sweat, okay? You can't expect that kind of workout is going to make you much stronger, or because the way your body works is that, if you try to lift something very heavy and you wear out your muscles, then your body will come back and say, we got to make these muscles stronger. And that's how you gain strength, right? And similarly, if you write code and the exercises you do are very easy and they come all naturally to you, and you never reach some form of challenge, then you can't expect your brain to say, oh, you know what, we need to get better, okay? On the other hand, if you have an assignment and it's tough and you have to think and you get kind of tired thinking about your the code that you have to write, if your brain struggles with it, then what's going to happen is your brain says, you know what, that was tough. Can we make it easier in the future? And when you go to sleep and it's important that you get rest, your brain is going to form new neuron connections and you'll get better, right? Just like, when you first had to like learn how to ride a bike or something like that, in the beginning, you kind of kept losing balance and eventually you got better, right? And similarly, when you write code in the beginning, it's going to be clunky. You're writing like nested for loops that are terrible and it's not efficient and stuff like that. But then you say, well, can we improve this? And you struggle through it, and you'll get better, right? When it comes to when it's like plagiarizing, right? If you go out and you say, I don't know how to do this, this is hard, I'm going to go on the internet, I'm going to just try to just find a little hint to do something, okay? It's a lot like going to the gym, finding some weights that are hard, like you can't lift the weights, and you say, you know what? Hey, you're a strong person over there. Can you lift the weights for me? Okay. Now, if the goal was for the weights to be lifted, sure, that works well, right? But the goal of going to the gym is not that the weights get lifted. The goal of going to the gym is that you gain strength, right? And having someone else lift the weights for you is not going to help you gain strength, okay? You have to be able to lift the weights yourself if you want to gain the strength. And similarly, when it comes to writing code, finding someone else's answer and copying their answer is not going to help you get better at writing code, okay? You have to struggle through it yourself, okay? And so don't cheat yourself out of the opportunity to improve and get better by looking at someone else's code, okay? All right, we have a question here. It says, do we need to provide explanations or comments with our code? It depends on the assignment. Are you only allowed to use base R? Are we allowed to use the tidyverse? Again, depends on the assignment. I'll make it clear what you're allowed to use and things like that. In general, if I introduce some kind of package or system in lecture, those packages you can use. And I'm going to just request that you do not use outside packages that I haven't mentioned in a lecture, right? So probably you can find some package somewhere out there that already does all of this stuff. I'm sure there's a package that includes a prime factorization function already in there, but please don't just say, hey, I found this package and there's my answer for the prime factorization problem, right? Okay. All right, so let's talk about plagiarism and stuff like that, right? So some students plagiarize, some students cheat, okay? And there's a few approaches we can take to this, and one is like, these students are evil and bad and lazy and things like that. And I don't know if that's the case. I don't know if I agree with a statement like that. I think the biggest motive, or the biggest reason why students might plagiarize, is that these students have confused the goals of the course. Students who plagiarize, I think mistakenly believe that the goal for them is to get good grades or avoid bad grades in the class. And the goal of learning and improving their ability to code is secondary to getting a good grade, right? But that's wrong, okay? The goal of the course is your learning. And I really want to kind of emphasize that, okay? And I know, it's, it's a little bit of conflict, because I wish we could just create some kind of individualized grading schema for each individual that says, like, did you learn and get better? And if you learned and you got better, then, you can get an A and things like that. But unfortunately, that kind of system doesn't quite exist, okay? But I hope you as a person can, grow and develop to the point where you can judge your own performance in the class based on what you learned, and not necessarily your lettered grade, right? You might end up with a lettered grade that's a little bit lower than what you have liked, but you look back and you say, you know what, I started off this class and I was only able to do this much, but by the end of the course, I'm able to do a lot more. And because now I'm able to do a lot more, I feel a lot better about myself, right? And just like, again, if you're thinking about like working out at the gym and getting stronger, you can't just compare yourself to, Arnold Schwarzenegger and say, I'm not able to lift as much as him, or, The Rock or something like that. So therefore, I don't feel good, you have to say, you know what, when I started off this year, I was only able to do this much. And now after, weeks of hard work or months of hard work, I'm able to do a lot more, right? Of course, we're not gonna achieve the strength of The Rock, but we're able to do a lot more. And I want you to feel good about that, okay? And so that's what we have, right? Okay, so this is my expectations for you. I want you to work hard. I do not want you, all right? Do not search out answers online or things like that. Don't ask former students for their code or their answers, okay? And if you're not able to answer all of the homework by the deadline, turn in what you have, okay? You're not going to get 100%, But I want you to be okay with that. You can say, you know what, this is the best I was able to do within the time frame. This reflects the best of my abilities. Okay. And it's not 100%. I didn't get everything right, but I feel good about what I've done. Okay. We do take issues of plagiarism seriously, and if we find some problematic cases and things like that, we will report it to the dean of students, but it's not a process I enjoy. I don't want to do that, right? Okay. Oh, I'll post a collaboration policy, and pretty much the policy for collaboration is you can talk about ideas, but you can't show your code to each other. So on Campuswire and things like that, you can talk about ideas, okay, but you can't actually post your lines of code, right? So for example, you're allowed to ask, how do you approach this problem? And there's lots of ways to answer this that don't break the rules, right? You can say, I created a loop, and within each iteration, I did this, right? We're not actually showing you the code, right? And, but if you say, hey, this is what I did, and you end up showing kind of the lines of code that you wrote, that breaks the rules, right? If someone says, can I show you my problem, or can I see how you did this? Don't show them your code, right? So showing the actual code or copying lines of code, that breaks the rules. But you can talk about, there's a lot you can still do just talking verbally, right? You can say, try using this function, try looking up this topic, or things like that, right? If you're allowed to kind of post error messages, right? So if you encounter some kind of error message, right, and it says, the error message I get is missing value where true false is needed, right? You're allowed to say, you can respond and say, you know what, if you have an if statement and whatever's inside the if statement evaluates to an NA, that's often where you're going to get that. Whereas if you just say, hey, let me see your code, that's going to break the rules, right? The exception is you are allowed to show me, and you are allowed to show Andrew, your TA, your code. All right. So you can show me or Andrew your code, and we can kind of take a look if you're truly, truly stuck. Okay. But showing your code to other students or having other students look at your code to kind of debug it and things like that, that's against the rules. Okay. Everything else. So I do post code in my lecture notes and things like that. You can copy code from my lecture notes and discuss those chunks of code, right? So you can talk about code and you can share code as long as it's related to some kind of concept or lecture and not to a homework problem. Okay, any questions on that? All right, we've got a lot of stuff to cover, but I do want to talk a little bit about this, about grades in life, right? And so this is just a bit of an aside, but I think it's important. I do want to say this. You're all here at UCLA, okay? And the reason why you're at UCLA, okay, UCLA only admits students who had good grades, right? You either had good grades in high school or you had good grades at your community college, okay? And so you're here at UCLA because you had good grades, right? And while you're in class, a lot of your time, a lot of your energy, sorry, my kids are chatting away over there. A lot of your energy is being poured into class, and it feels like you're all working towards some grades. So it feels like grades are really important, okay? And it feels that way, but it's important. Your grades do not define who you are, okay? Your grades are not who you are, right? And I get it, right? In high school, I got good grades, and in college, I tried to get as good grades as I could and things like that. And it feels good to get good grades, and it feels bad to get bad grades. And, grades do play a role in like grad school admissions and things like that, but they're not the most important things in life, right? You're not going to go like looking, if you reach super old age and you're on your bed and you're about to die, you're not going to look back and go, oh, my life would have been so different if I had an A- instead of a B+. I wish I did that. That's not what we're going to do. Okay. you're going to look back and you're going to say, yeah, I wish I invested in people more or something like that, right? So, oh, this is story time. So, and I say this because, I had to go through kind of this traumatic, I don't know how traumatic, this difficult experience to kind of learn this lesson, right? So in high school, I worked really hard to get very good grades, and I got into my dream school at the time, which was Caltech, California Institute of Technology, and I got in there and I thought, yes, this made all of those nights of studying and all of not that I was gonna go to parties anyway, but like I didn't have much of a social life in high school, and I felt like it paid off. I got into my dream school, and then I attended Caltech in the fall, and my first quarter at Caltech, like I felt like I was drowning in my schoolwork. I got my first, so Caltech's on the quarter system. So I understand the stress of like when week 7 rolls around, how like everything you're juggling feels like it's falling down. But so fall quarter, I got my first C ever. And I thought, oh my gosh, I've never gotten a C before. And then winter quarter, I got my first D ever. And I thought, oh my gosh, this is no good. And then spring quarter, the linear trend continued, and I got my first F ever, and I got multiple Fs, and I was put on academic probation. And I just thought, oh, and I had, and I fell into depression at the time, because up until then I had tied so much of my identity and who I was to my grades. In high school it was like, I only have a few friends. I don't have much of a social life or anything like that, but that's okay because I have good grades, and this is how I feel good about myself. But and then when I got into college, like that all fell apart, and then like if I have bad grades, then who am I? What am I, right? And so that summer I didn't know what to do. I thought, how am I going to go back to Caltech, and I have to get off of academic probation. I don't even know how to get my grades up. But then, what am I supposed to do? Drop out or things like that? Thankfully, and I'm so grateful to my parents. My parents, and my father especially, were just very supportive. And my dad's told me that it's not worth kind of the stress and the anguish that I'm putting myself through to hang on to this dream of going to my dream school. And so he encouraged me to transfer schools, find another school. And so that's what I ended up doing. I ended up transferring out of Caltech, going to another school that was easier, and I completed my engineering degree there. And anyway, but it took that experience of kind of failing a bunch of classes, wondering who I was if I didn't have good grades, to realize that my identity and who I was did not need to be tied to my grades. And I'm thankful for that lesson. And I come to you and I tell you, and I share this story with you because I also want you to kind of be able to take a step back and say, the person I am, it's not the grades I get is not the most important thing in life. Okay. And so, yeah. Okay. So I was forced to let go of my dream, and anyway, yeah, forced me to find my self-worth, not in my grades. And, I found it in my faith and the relationships I have with others. That's how I see, that's how I find kind of value, not in my achievements, but in kind of the investments and connections I have. And so, when we talk about work-life balance, a lot of people wonder, like, how do you achieve a work-life balance between, schoolwork and personal life, or, your professional life and personal life and things like that? I like to think of kind of, these 3 large categories, broad categories, right? You can pour your energy into work, and that includes jobs when you're working, but also school when you're a student, okay? You can pour your energy into relationships, and that's going to be with your family, friends, if you have a romantic partner or any other kind of social obligations, that's there. And then you also you can pour your energy into yourself and care into your physical health, caring to your mental health, caring to your spiritual health. And, all of us, we have only 24 hours in a day, and it's not possible to give 100% to every single one of these categories. We can't do 100% to, any one of these things. It's not possible. So we have to kind of divvy things out, right? And the way we achieve work-life balance is by consciously choosing the things that are important to us and putting the energy in there, right? And in general, the more energy you put into something, the more you're going to get out of that thing, right? And kind of the flip side of that is the things that you don't put your energy and time into, there's going to be just natural consequences of that. Those things are going to kind of weaken or wither. And, these things that you put lower in terms of the priority list, if you can accept and be happy with just those things not being as strong as someone else who's putting a ton of time into it, I think you can find satisfaction in life, right? So, a silly example is, let's say you had, you're close with a group of friends, and then you find a romantic part, you enter a relationship with a romantic partner, right? And so now that you're in a relationship, you're spending a lot of time with your romantic partner, and you have less time for your friends. And so just the natural thing that's going to happen is you're not going to be as close to your original group of friends as you used to be, right? And at first, this can feel hostile. You can be like, why didn't you invite me out to the movie or whatever? And it feels like you're being excluded, and it's like you're being punished for being in a relationship or something. But it's not necessarily that they're being hostile towards you. It's just, they've recognized that they are, maybe less of a priority than what originally what it used to be, because now you have your energies have to go into something else, right? In my own personal life, after I had kids, I've had a lot less time to spend with kind of any of my friends, and so just naturally, my relationship with a lot of my friends and college and other things, like we've kind of just drifted apart. There's no ill will, no bad blood or anything like that, but just, a lot of my energy is now spent with my family and children, and I have a lot less time for, other friendships and relationships and things like that. Similarly, when you're working, the company, depending on the corporate world or company that you work in, there's going to be some employees, some of your colleagues will spend every waking hour doing work for the company, and they might not have a rich social life outside of work, okay? And you might be in a different situation where you do everything that your boss asks of you, but after the workday ends, you leave and you spend time with your friends, or your romantic partner, or your family, or whatever, and things like that, right? And so when it comes to a time for a promotion, who is more likely to get promoted? The person who did everything asked of them and continued to stay work and did even more, or the person who did everything asked of them but then leaves immediately, right? And probably from the company's perspective, they're going to say, oh, you know what, this person who did way more, gave up all of their social life and stuff like that to work for the company, deserves the promotion more. And so, that might mean choosing family and friends and a romantic partner, things like that, might mean somebody else gets picked for a promotion. And if you can kind of accept that and just say, you know what, that makes sense. I wasn't as dedicated at this person, but that's also not the life that I want for myself, then I think you can be happy with that. Okay. All right. I've been talking a lot about this kind of stuff. Make sure you don't ignore your physical health or your mental health or things like that. If you ignore those things, you yourself will probably be operating at less than 100% efficiency. If you're not taking care of your physical health, you might get sick, you might be tired, you're going to be, your time spent hanging out with people or studying will be less effective and things like that. So make sure you take care of yourself. Okay. Sometimes you will hear me say things like, I want you to make a priority of your mental and physical health, okay? And you might feel like, how can you say that and also assign this long homework assignment at the same time, okay? And what I'm trying to say is I want you, okay, to be able to be in a position where you say, you know what, my mental health, my physical health, the fact that I'm going to get some sleep is more important than getting 100% on this assignment. Okay, I want you to be able to reach a point where you can say, taking care of myself is more important than getting 100% on the assignment. Okay, and so that means you're going to say, well, I'm going to go to bed. I stayed up late. I'm not done, but I need to sleep. So I'm going to just turn in what I have. You're not going to get 100% on the assignment if you didn't finish it all, right? Like you might get some points lost, but I want you to be okay with that. I want you to be able to say, you know what, sleep is important and I'm going to get the sleep that I need. And you can say, well, you know, I'm not going to get 100%. That's okay. So that's what I want you to be able to do, right? And so in my own personal life, taking care of my mental and physical health and my relationships is more important than, it is important. And so that means sometimes I get a bunch of emails and I just say, you know what, I've done my work for the day. I didn't respond to all of these emails and I got to be okay with that. And sometimes that means some of these students will be angry because I didn't respond to all of the emails, and that happens. And I apologize in advance if you send me an email and it takes me like 5 days to respond. Sometimes that happens. But I'm okay. I'm okay with kind of the relationship that I have with the amount of work. I think I do a good job in terms of communicating and doing my job as a teacher. But it also means I've drawn boundaries between how much time I'm going to be spend responding to emails and messages. And again, come to office hours, you'll get a much faster response than things like that, than send me a message. Okay. Okay. Oh, all right. Okay. One last thing. Sorry. Fruitless entertainment. Okay. Entertainment, I'm all for entertainment and fun activities. It's very important, right? It's very important you do things that are fun. It's very important that you have fun and you find things that are entertaining. That's very important as far as refreshing your mental health and things like that, okay? So, you know, watch TV, watch a movie, play a game, things like that. Do those things. Those are great, okay? But I do want to warn you that there are a certain class of activities that I consider fruitless entertainment, okay? And these are activities that, so the idea of having fun and taking a break is that after you finish having fun and you take a break, you feel refreshed and you feel like, oh yeah, I can go back and I can tackle my work, and you're in a better mood, okay? But there's certain games, certain activities, certain things that you spend like hours on them and afterwards you don't feel any better. These things actually kind of drain you, right? And a lot of these things have been kind of designed to be addictive, not to actually put you in a better mood, but just designed to be addictive and keep you hooked, to get, you know, more views and more advertisements pumped into your face and things like that. And while you're doing it, it just kind of keeps hitting these, you know, little dopamine buttons in your brain. And so that's why you keep kind of doing the infinite scroll and things like that. But afterwards, you don't feel good about yourself. You don't feel refreshed and ready to go back and do work. And I want you to just take a moment and evaluate if there are activities in your life that are kind of fruitless in this way, right? Because when we do take breaks for entertainment, and you know, and we're having fun, we should feel better. We should feel like, hey, that was great, and other stuff, you know. So think about that. I want to kind of warn you about that. And so I've made changes in my life. I've cut out certain social media things, and I have to say that I think my life is better. You know, that's not necessarily going to be the answer for everybody, but I do think taking some time to just reevaluate some stuff is good. Okay. Thanks for hearing me out for all of that stuff. Okay. Let's get into actual programming content with R and things like that. Okay. I'm assuming all of you has RStudio and stuff, R and RStudio installed on your machine. Okay. So a few things. When you work in R, a lot of times you need to kind of import data, you need to output some files and things like that. And a lot of times you might run into problems because it can't find a certain file, right? And so my recommendation is each homework assignment should kind of go into its own folder, like make a folder for homework 1, make a folder for homework 2, put all of the files related to homework 1 in that folder. And then when you're working, you're going to set your working directory. You're going to go to the menu and do session, set working directory to kind of your source file location, right? So you open up the file, all of your related files are in there. You do this, this will help find your thing, okay? You can also set it manually, right? You can also set the path, and depending on whether you're on a Mac or PC, you might have different kind of the ways to write paths, okay? If you're on a Windows PC, you might have to use forward slashes, which is not the typical slashes used in directory structures, or you might have to use double backslashes, okay? Another big thing is clearing your environment. So a lot of times students will run into issues with when they're trying to knit their files, right? And so one thing that happens is as you're working, you end up creating objects. You end up creating little vectors and data frames and things in your environment. And these have been created in the console, but maybe the instructions to create them don't necessarily exist in your R Markdown file. And so when you try to knit them, you run into problems. So what I often recommend is that you kind of clear your environment, and you always kind of start with a clear and empty environment whenever you start working on a new project, okay? And kind of going on, and this is another way you can kind of clear the environment from the console, just typing this in, rm_list equals ls. But you can also just click the broom. The broom is just, I think, the fastest way to clear your environment. And going along with that, okay, and this is really important, is that when you load up R, change your options. Let me make my text bigger. Under global options, I have a dark thing. Make sure you do not restore your RData workspace at startup. And then when it says save workspace to RData on exit, choose never, okay? And I strongly recommend that. And that's because sometimes when you load up a workspace, it's gonna change some settings and it's gonna load up certain files and things in your thing. And it can just kind of end up confusing stuff. So I strongly recommend always starting, when you start R, start empty, and you don't actually save your workspace when you exit. And I write my justification here. You can kind of go through that. But basically, it forces you to explicitly save anything you want to save. There's a few shortcuts that are helpful in RStudio. You can turn any kind of line into a comment. You just hit Command-Shift-C, and it toggles things into comments. So you can take like entire lines of code, Command-Shift-C, they all become comments. You hit Command-Shift-C and they all uncomment and things like that. So it's pretty great. Anytime you want to create a new script file, you can just do Command-Shift-M or Control-Shift-M. You can run lines of code. You can hit just Control-Enter, Command-Enter. Oops, what did I do? Control-Enter, and these things get run. You can also kind of run code chunks by hitting the little play button. Let me just clear this, and you can just hit the play button and it runs, okay? Okay, and if you want to kind of run the entire script, you can take a script and you can write source the script, and it will run everything. Okay, other useful things to kind of clear out your console, you can hit Command or Control L. So this is the console down here. You can clear everything out there. If you need to restart your R session, you can hit Command Control Shift F10, Command or Control Shift K to kind of knit a file. Okay, all right, this part, the rest of today's lecture, I think, is a review of stuff from Stats 20 and I have like 100 slides to get through, and I've got like 55 minutes to do it. So we're just gonna kind of blitz through a lot of this stuff. If you've got any questions, just don't hesitate to raise your hand or enter a question in the chat. A lot of this is review, I think, from Stats 20, but I kind of want to just make sure we cover all of this in a good amount of depth. Okay, so you guys work with vectors, right? And you've got kind of two types of vectors in R. You have atomic vectors and you have generic vectors. This is a rhetorical question, but what's the main difference between an atomic vector and a list? A generic vector we might call a list, okay? And the answer there is that the atomic vector has to, I guess the answer wasn't written here. The atomic vector, everything in there has to be of the same data type, whereas a list is allowed to contain values of different data types, okay? So what are the different data types we have? Okay, the types we have logical values. Those are your true false values. You have double, which is basically numeric values with a decimal. Integer values. You have character values. You have complex and raw. We generally don't use these very often, but complex, if you've got imaginary numbers, raw is like stuff in hexadecimal format, but pretty much the first four are going to be your most important ones, okay? And in an atomic vector, everything must be of the same type, okay? R doesn't, will convert between integer and double or floating point values with decimals automatically, so we often don't need to worry about the distinction. But one important difference is that double numeric values are stored with floating point precision, okay? And integers are stored as exact integer values, all right? And so we'll get into we'll have a lecture talking about floating point precision later, okay? If you want to create, anytime you type a number into R, so if you just type in a 3, this is going to be a type double 3. If you want an integer 3, you type 3L, and this one's an integer, this one's type double. It seems a little silly, but I can do type of 3, and that's double, type of 3L, and that's an integer. Okay. And if you use the colon operator, that's going to be integer type. All right, so here's a few differences, right? So 1, 2, 3 is double, 1:3 is integer, things like that. Okay. So your atomic vectors and your lists are one-dimensional structures, okay? But we can also create two-dimensional structures. And if everything is the same data type, the two-dimensional structure is going to be a matrix. We call that a matrix. And if things are of different data types in a two-dimensional structure, so you have like a column of numbers and a column of character values, that would be a data frame, okay? You can also create higher dimensional structures like a 3-dimensional data structure or 4-dimensional, n-dimensional thing, and they all have to be of the same data type, and that would be an array. There's no data structure that has higher dimensions than 2 that allow for different data types, okay? So this is what we've got. When you create a vector, you can attach attributes to the vector, okay? Attributes can really just be anything, okay? It's just a list. Attributes are stored in a list, so a list can contain kind of any kind of data, even like functions and stuff, okay? And they just get attached to the to whatever vector you have, right? And there's two kind of important attributes. One is the dimension, and if you have an atomic vector and you attach a dimension attribute, it will actually turn the atomic vector into a matrix or an array, okay? And then you also have something called the class, which we'll talk about object-oriented programming in a future lecture. But the class attribute is what powers the object-oriented system S3, okay? So this is questions you can ask yourself later when you are studying these notes. If you want to kind of look up the attributes of a thing, you can use attributes, and this will give you the list of all of the attributes, okay? And ATTR will give you one single attribute, and will allow you to actually change one single attribute, right? So for example, there is a data frame called trees. The trees has information about the girth of the tree, the height of the tree, and the volume of the tree, okay? And so we've got 3 columns and things like that. Okay, what are the attributes of this data frame? Okay, the attributes of the data frame are the column names. So this is a list, okay, it's a list. So under the first element of the list, we have the names, which are the column names of the data frame. We have the class, which says this is a data frame. And the data frame also has row names, okay, and apparently there's 31 elements. 31 rows in the data frame, and those row names are just these numbers 1 through 31. Okay, there's actually, as far as the data frame goes, there's no dimension attribute. If you ask for the dimension of a data frame, it's going to tell you it's 31 rows by 3 columns, but it's getting that by seeing the length of row names and the length of names. Okay, it's again, attributes are just some arbitrary lists, so you can just add whatever you want. So here I'm going to just say, I want to add an arbitrary attribute called info, and we're going to attach it to the trees. And this is going to be just this string that says this data frame is about trees. Okay, and you can do that. You can add whatever you want. You can just, it's a list. A list can store pretty much whatever you want in R. So you can just take some attribute about something and you can just add that to it. Okay. So let's take a look at something else, right? So here, I'm going to create an atomic vector M. M is just the values 1 through 10, right? And if I say, okay, what is the class of M, all right, or the mode is technically, it's just an integer vector, right? Now here, I'm going to just take the dimension attribute, which actually there's no dimension attribute here. If I say, what are the dimensions of M? It would come back and say there's no null. It would say null. There's no dimensions for M. But look what happens. If I just say, hey, you know what? Let's add a dimension attribute to this atomic vector, and the dimension attributes will be 2, 2, 5, this vector 2, 5. It's suddenly going to reshape this vector into a 2 by 5 matrix. And it fills it out column-wise and goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And so effectively, a matrix is just an atomic vector with a dimension attribute. And so you can just kind of take a vector, add a dimension attribute. So here, if I say, what are the attributes in M of that matrix? It says you've got a dimension attribute. The dimension attribute is 2 by 5. And when you say, well, what is the class of M? The class function is smart enough to say, you know what? It used to be an atomic vector with integer values in there, but now that it's got a dimension attribute, this is a matrix, and it figures that out. Okay. And so if you take this, which currently the attributes of M has these dimensions in here, right? And you can kill that. You can say, I want to set the dimensions of the attribute to null. Okay. So this is basically going to take the dimension attribute and just delete it we're going to set null, the null object to this thing. And so M is going to turn back into this atomic vector of length 10. Okay, so again, here M is, I'm going to just do 1 through 12. Okay, so M is just this atomic vector. I can say, what are the dimensions of M? Right now it's null. Okay, and here I can set them this way too. And I can say, you know what, I want to do it like this. And I can say I want the dimensions of M to be 3 by 4. And now it's a matrix. M is a 3 by 4 matrix. All right. What are the attributes? It's a dimensions 3 by 4. I can say, you know what, let's take the dimensions of M, null them out. Okay. And now M is back to a length 12 vector here. Okay. And it's type integer. Okay, so you can do that. Similarly, here you can do something like that for an array. You can say the values 1 through 12. This is going to be just a vector. You can set a length 3 vector, the vector 2 by 3 by 2, and this will create an array. 2 rows 3 columns and 2 sheets. Okay, 2 rows, 3 columns, 2 kind of layers or 2 sheets to create a 3-dimensional structure. So far, so good? All right, great. Okay, data frames, again, is this 2-dimensional structure here. We're going to just take a look at the first 4 rows of this data frame trees here. And internally, a data frame is stored as a list. It's a list of multiple vectors. Here, I've got 3 vectors inside this list, a girth list, or a girth vector, height vector, and a volume vector. And those vectors are of the same length, and this creates a data frame, okay? So if you say, what's the class? It's going to say it's a data frame. But if you say, what's the typo, which is kind of the internal structure, it's built out of a list. Okay, we'll talk more about this kind of stuff later. You also have factors, okay? Factors can be used to represent categorical variables, right? And so internally, a factor is stored as an integer vector, and you have levels and class attributes, okay? So here I've got a character vector for, say, genders, and we've got, you know, male and female, or masculine and feminine, unspecified or non-binary or something like that, okay? And we can just take this character vector and we can throw it into this function factor, and that will convert this character vector into a factor. And so when you say, well, what does the factor look like? Now it looks like this, okay? And we can tell that this is not a regular old character vector, because if it's a character vector, you get quotes around every element. Here, there's no kind of quote signs, and it also spits out this thing called levels, right? There's levels attribute. The levels attribute is just a character vector of what the levels represent. So so internally, this is stored as kind of the integer 2, 1, 1, 3, 2, 1. Okay, and we have kind of this thing that says whenever you see a 2, it's an M. Whenever you see a 3, it's an X. And whenever you see a 1, it's an F. Okay, and that's what the levels represent. I've got questions in the homework that have you explore a little bit how this works. Okay. And so if you take this gender factor and you say, turn it into an integer, again, the M's get turned into a 2, the F's are stored as a 1, the X is stored as a 3, right? And the way R goes from these integer representations to kind of the character symbolic representation is it's using the levels attribute to do this. Okay. So one thing you got to be careful is that if you have a factor, if you have a kind of a vector of numbers and then you turn that into a factor, okay? So here I've got 0, 1, 10, 5, okay? You can, it looks like numbers here, but this is actually not numbers. These are stored internally as vectors, right? So I got 0, 1, 10, and 5. If I say, what's the mean of this? It's going to say, well, you can't do that. And so you can say, well, you know what? Let's turn the X as a factor, okay? And ask for the factor into a numeric variable and take the mean. And if you do that, you get the number 2.5. And if you're not careful, you'll be like, oh, the mean of these numbers is 2.5. But if you think about 0, 1, 10, and 5, right, those add up to 16. The mean of 16 over 4 is 4. The mean should be 4, okay? And what's happening is that when you do as numeric as a factor, numerically, it's just stored as 1, 2, 3, 4, okay? This is this is a 1. This gets stored as a 2. The 5 gets stored as a 3, and the 10 gets stored as a 4, right? So these are kind of, we're treating these as categorical variables. And so even though they look like numbers, they're actually categories, okay? It's like category 0, category 1, category 5, category 10. And it doesn't, and internally, they're stored as these integers, 1, 2, 3, 4. And so if you try to convert them into numbers and then do calculations with that, it doesn't make sense. Okay, does that kind of make sense what's happening there? So if you wanted to kind of get around that, you can take the factor, turn it into a character, And that will turn these into 0, 1, 10, 5 as characters. And then you can say as numeric on the character vector 0, 1, 10, 5. And then R will be able to figure out, okay, these are now the numbers 0, 1, 10, 5. And then you can calculate the mean, which will be the number 4. Okay. I might have gone through this a little bit quickly. Hopefully, I've got some questions in the homework that kind of cover some of these ideas. And hopefully when you work through the homework questions, you'll be able to understand and understand what's happening there. Okay, if you try to combine factors using the function C, which we use to kind of build vectors and things like that, it's not going to work because internally this factor, it stores the A as a 1 and the B as a 2. And internally this factor stores the B as a 1 and the C as a 2. And so when you try to combine them, you're going to get, 1, 2, 1, 2, which is probably not what we wanted. Okay. And then if you try to assign values to a factor, right? So our factor for the genders, we had M, F, and X. If you try to assign something that's not one of the levels, you get a warning here, and it generates a missing value in NA. With atomic vectors in R, again, with an atomic vector, everything has to be of the same data type. R performs something called coercion. Anytime you try to mix two vectors or elements of different types into one vector, because R requires everything to be of the same data type, it's going to kind of coerce values into other data types. Okay, so here I've got a logical vector, which contains the values true and false, an integer vector, which contains the 1 as an integer, a double vector, 5, 6, and 7, and a character vector, which contains the characters A and B. And what it will do is it will kind of combine these into kind of the least restrictive type. So if I combine the logical, the integer, and the double, it's going to coerce everything into a type double, and we're going to get a double vector. If I combine the logical, double, and character, it's going to coerce everything into the character type. So let's take a look at what happens, right? I combine the logical, integer, and double. This logical vector, which has true, false, the logical true and false get converted into a 1 and 0. Okay, the true becomes a 1, the false becomes a 0. Okay, we have the values 5, 6, 7, the integer 1 remains a 1. And all of the elements here are type double. Okay, whereas over here, if I combine the logical, the double, and the character, it's going to convert everything into character type. So the true becomes the characters TRUE, the false becomes the characters FALSE, the 1 becomes a, I did logical integer, have a typo here. This should have been the D and the CH. The integer becomes the 1 in quotes, and then the character values A and B remain character values A and B, and this is character type. So that's, those are stuff being coerced. Okay. You can explicitly coerce anything you want by doing as.numeric. Okay, so you can do as.something, as.logical, as.numeric, as.integer, as.double, as.character, and that will explicitly coerce values into that type, right? So you say as this, and it's going to coerce it. But then other functions will just kind of implicitly coerce it. It's going to say, hey, you know what, you're giving me stuff, and I'm expecting values of a certain data type, and it's going to coerce them automatically, right? So here I've got this vector trials. It's a logical vector. We've got false, false, and true, right? And so if I say, you know, convert this explicitly into numeric values, this will say, okay, false becomes 0, true becomes 1, and we get 0, 0, 1. If you take this, though, and you give it into the function sum, okay, sum is, it's a function that is expecting numbers. It sees logical values, and so it's going to coerce these into numeric things, and it's going to give you the sum, and it's going to give you 0, 0, 1. So even though I gave the logical vector directly, it's effectively coercing it into 0, 0, 1, and it gives me the sum of that, which is 1. Over here, it's basically going to coerce everything implicitly into these numbers 0, 0, 1, and gives me the the proportion of ones and trials, which is going to now be 0.33. Okay. the explicit coercion, anytime you have an as dot something, that's going to explicitly coerce it. So zeros and ones become false and true. If you try to coerce something that it can't figure out, right? Like here's a word cat, turn that into a number, it's going to say, I don't know what you're trying to do. Okay, so it can't do that. So these are the rules regarding explicit coercion. Okay, anything that is not a zero is going to become true, except for nan. Okay, so 0 becomes false. -1, 0.1, 2, negative infinity, all of these other numbers, everything becomes true. Nan becomes missing NA. Okay. This is the accepted spellings for false and accepted spellings for true. Capital F, capital FALSE, capital false, capital, lowercase false. Okay. Lowercase f, lowercase t, anything else, if you try to turn it, it's going to turn everything into NAs. Okay. But all of this stuff, these will get converted into false and true. All right, let's talk about NA, null, and nan. NA, null, and nan. Oops, someone's phone is ringing here. Okay. So NAs are used for missing values. Okay, and you have there's actually an NA for each data type. There is a logical NA, an integer NA, a character NA, and things like that. And we'll talk about that in a moment. Okay. Null is used to represent anything that is non-existent or empty. Okay. Null is its own data type. So NA and null is not the same thing. NA is for missing, if something is missing, which is different from something that doesn't exist, right? So if something doesn't exist, that's a null. If we just don't, if it exists, but we don't know what it is, that's NA, okay? Nan is used for not a number. It's a type double, but it's used to represent kind of indeterminate forms. So if you try to do 0 over 0, or what's positive infinity plus negative infinity, you're going to get nan, right? So internally, you have an integer nan, a real type double, which was called real nan, character nan. Why do we have all of these things? Okay, well, it's because in an atomic vector, everything has to be of the same data type, right? And so if you want a missing value in a character vector, that missing value has to be a character value missing. Okay, if you have a missing value in an integer vector, it has to be a missing integer value. Okay, now when you do NA, this is a logical type. This is the most restrictive one, and so it's going to just get coerced into whatever these things are. R is unique in this way. Okay, I think R is one of the, I don't know very many other programming languages that have an explicit NA value. Python uses nan as kind of a substitute for missing values, but it's not exactly the same. It's a little different. Okay. If you want to check to see if something's missing, you can't do NA equal NA. This will always return NA. You have to say, is it missing? Is .NA, and that's going to return true, right? Because equal is basically saying, I've got a value in this mystery box. I've got another value in the mystery box. Is the mystery value equal to this mystery value? And the answer is, I don't know. Okay. On the other hand, we say, is this an unknown value? We can say, yeah, this is an unknown value. That's going to be true, right? So if you want to check for that, you do that. Okay. The null is the null type. If you ask for the type of on null, it's null type. And you can ask, is it null? And that's going to be true. Okay. If you ask, is it missing? You get this. What is this? This means this is a logical vector, but its length is 0. Okay. So the null is basically, the length of a null vector is 0. Okay. It basically doesn't exist. And this tells us that the vector is.NA is always going to return a true or false or a logical answer, right? If is the thing missing yes or no. The answer, it's basically, the answer to this question is a yes or no answer. So it's going to be a logical type thing, true or false. But here there's a length 0 element here, and the null is a length 0. And so its response is a logical vector of length 0. Is the vector logical though? Is null a logical vector? That's going to be false. Okay. All right. So this is interesting here. Okay. So if you try to add null plus something, right? If you try to take two things and you add null with it, you're going to get a length 0 vector, right? So plus, what's happening here, the plus coerces the false into an integer type. This is going to be a 0. And we're trying to add a non-existent thing to an integer. And so we get a length 0 integer, right? If you try to include null, it's like including nothing into a vector, right? So if I combine 4, 5, null, and 3, we basically just have a vector 4, 5, 3. Okay, what's the length of 4, 5, null, 3? Well, it's a length 3 vector. Null just doesn't exist. This is like a nothing thing, right? Is nothing equal to nothing? Well, there's no answer there. It's a logical vector of length 0. This feels weird, okay? But again, null just represents kind of this non-existent thing, okay? You got a few exercises playing around with null and nan and stuff. Okay, I think you're familiar with the vectorized arithmetic in R. So here I've got two vectors of equal length, 1, 2, 3, and 100, 200, 300. If you add those, they get added element-wise. So the 1 gets added to the 100, 2 gets added to the 200 for 202, 3 gets added to the 300 for 303. When you multiply them, they get multiplied element-wise. 1 times 100 is 100, 2 times 200 is 400, 3 times 300 is 900, okay? When, if you have vectors of different length, then the shorter vector gets recycled, okay? So when I add 1, 2, 3 to 100, 200, 300, 400, 500, 600, okay, then we're going to add 1, 2, 3 here, and then we're going to recycle it, and we'll get 400 plus 1, 500 plus 2, and 600 plus 3. Same thing happens here, except we're going to get a warning. R is going to say, are you sure you wanted to do this? It's going to add 1 to here, 2 to this, 3 to this, add 1, add 2, and then it says, hey, you know what? I've got a 3 left over. I'm not sure if this is what you wanted, okay? So we get this, right? We get 101, 202, 303, 401, 502, 603. Here I get pretty much the same stuff, 101, 202, 303, 401, 502, but it says, here's a warning. The longer object length is not a multiple of the shorter object length. And I ended up with stuff left over. And so you get a warning because R just says, you know, I did my best, but to be honest, I don't know if this is really what you wanted me to do, okay? Okay, here I've got a matrix, right? 1, 2, 3, going row-wise, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here I'm gonna add this vector, 100, 200, 300. The recycling is done column-wise. So it adds 100 to the 1, 200 to the 4, 300 to the 7, 100 to the 10, 200 to the 2, 300 to the 5. All right, and so it goes 1, 2, 3, 1, 2, 100, 200, 300, 100 to 200, 300, 100, 200, 300. And it doesn't complain. It says, oh, you had 12 elements. Here I had 3 elements. 3 fits into 12 evenly. This may or may not be what we wanted it to do, right? We might have wanted it to go 100, 200, 300, 100, 200, 300, 100, 200, 300. But it's not doing that. It adds it down the columns. So if you wanted to do something like that, where you get it added across the columns, 100, 200, 300 across the column or row, and we want 104, 205, 306, 107, 208, 309, you have to get a little bit creative, okay? So what I'm going to do is I'm going to take this matrix, I'm going to transpose it, then I can add X, and it adds them column-wise, and then I transpose it back, okay? And so now I've added 100 down the first column, 200 down the second column, and 300 down the third column. Okay, so it just requires a little bit of creative thinking, but you have to kind of transpose it because R is always going to be adding down the columns. You can't just say like, when I add it, I want you to add it across the rows. R doesn't know how to do that, right? So is that okay? What's happening here? I transposed it, added it column-wise, transposed it back, so now it's adding across the rows. Okay, let's talk about subsetting. And again, I got 25 minutes, 60 slides. We'll see what we can do. Okay. All right, so here is just a simple vector, type double vector. The numbers are 2.1, 4.2, 3.3, and 5.4. The part after the decimal, the 0.1, 0.2, 0.3, and 0.4 kind of is used so that it gives you the original position. The 0.1 is in the first position, the 0.3 is in the third position, the 0.4 is in the fourth position. Okay, so we can subset this a few ways, right? You can subset with integers, positive, negative, integers, and vectors, logical and character vectors. So if you say I want to subset with 3 and 1, it will return the third and the first value in the order that you tell it to subset. The value order X gives you basically, if you wanted these to be sorted from least to greatest, what is the index that you would use? So if you take X and you subset using the order of X, it will say put in the first element, then the third element, then the second element, and then the fourth element, and that will arrange it in sorted order from least to greatest. So that's what order X will do here. Okay, if you provide the same index more than once, so here I say X subset on 1 and 1, it says, sure, here's 2.1 and here's 2.1. It has no problem giving you the same element multiple times. If you give it real numbers, like something with the decimal, right? And you say subset X giving me element 2.1 and 2.9, it's just going to truncate everything, right? And so it gives you the second element. So it's not rounding. You give it 2.9, 2.99, it just gives you the second element, 4.2. Okay, you give it negative integers, and it's going to omit this, right? So this says omit the third element and the first element, and it would get back 4.2 and 5.4, the second and fourth element, okay? You're not allowed to mix negative and positive integers, right? So it says omit the first element, give me the second element. And then it says, well, I'm not sure what you want me to do. You want 4.2 or you want 4.2, 3.3, and 5.4? I'm not quite sure what you're talking about here, okay? So it says you can't mix negative subscripts there. You can subset using a logical vector, right? So here I can say, so it just goes element wise, true, true, false, false, right? So I want 2.1, I want 4.2, true and true. I don't want this and I don't want this, so we get back just the first two elements, okay? Here you can have X greater than 3 is going to create a logical vector. So X greater than 3 will produce false for the first element, true for everything else. And so here this creates a logical vector, and it gives you everything that kind of satisfies that logical condition, which are all the values greater than 3.3. So no problem there. Okay. If you give it a shorter vector, then it gets recycled. So here I got true, false, and my X is a length 4 vector, so it's going to get recycled. And this is equivalent to basically running true, false, and so I get 2.1 and 3.3. Okay. If you have a missing value in NA, that's always going to correspond to a missing value in the resulting output. So I want true, true, 2.1, 4.2, NA, and then false. So this is what we get. If you do true and NA, the recycling applies. So we get 2.1 NA, 3.3 NA. Okay, so these are all kind of how you can subset with a logical vector there. And so this is very handy, especially, you could do calculations on one vector, get a logical output of the same length, and then use that to subset. If you put nothing inside your square brackets, then it's going to return the original vector. Okay. It's not useful for vectors in of itself, but if you're doing a matrix or something and you want to return all of the elements in the entire row or something, you can put nothing in for which columns you want and things like that. Okay. and can also be used in terms of assignment. And then if you say a 0, right, it's going to return a 0 length vector. So here X is a numeric or type double, and you can say, you know what, I want 0 elements out of there, okay, and so this will give you a numeric vector of length 0. Okay, it's a 0 length vector. It's not nothing. It's a vector of length 0, right? So it's a vector, but there's nothing in it. Subtle distinction. It's not the same thing as a null object. Okay. You can take a vector and you can give names to the vector. So here you can take a vector here. Again, X is this vector, 2.1, 4.2, 3.3, and 5.4. And we can give names to those elements. So I'm going to do set names, and we have letters. You guys know about the built-in vector letters, right? So if I just type in letters, it's going to be A through Z. And if you do all caps letters, it gives you A through Z in all caps. And these are very, very helpful. Okay. So anyway, we just say, you know, take the first 4 letters of the alphabet, set those as names for Y, and we're going to store this. So Y is now this vector. It's a vector with names. Okay. And so we can say, you know what, I want elements D, C, and A. This reminds me, I totally forgot. Let me give you your second view quiz answer, all right? So you had your first one all the way back at the beginning of class. Your second view quiz answer today is the letter C. C as in cat. C as in cat is your second view quiz answer. So jot that down. I hope you guys are still paying attention. Second view quiz answer is the letter C, okay? And then I'll give you your last view quiz answer later. Okay, so anyway, here, this is just like subsetting as you would expect. You would say, all right, I want element named D, element named C, element named A, and it gives you those elements in the order that you ask for them. Okay, and again, just like with the integer values, you can repeat the names. You can say, I want element A, and it gives you those things, all of them, right? If you create a vector, so here I'm creating a vector and I'm giving the names during the creation of the vector. So when you create a vector with C, you can give it the names. And so this is going to be the name ABC is the value 1. The name DEF is the value 2. Okay. And if you do that, it's got to, the names have to match. So if you say, I want element named A, and the name is ABC, it's not going to find anything. I want the element named D, and the name is DEF, it's not going to find anything. So it says, I didn't find anything that you were saying. I got missing values, NAs. All right, is that okay? Does this all make sense as far as subsetting these atomic vectors? You guys have all seen this before? Yeah, kind of. Okay, so here's some useful things that you can do, right? So if you want to make a lookup table, right? So let's say you had this, okay? You got M, F, U, F, F, M, M, and you say, you know what, I want to convert this. I don't want M's and F's. I want the word male and I want the word female, and we're going to have U be missing or something like that, right? So what you can do is here, the lookup is just this vector. It's a length 3 vector. And notice what I'm going to do. I'm going to subset the lookup vector, which is length 3, with this vector X, which has all of these elements M, F, and U, and things like that. And so it's going to find, okay, give me the element that corresponds with the name M, give me the element corresponds to the name F, give me the element corresponding with U, give me the element corresponding with F. And so we get this, okay? We get this. And then if we want to store that, we can get rid of this, right? So these all have the element names, M, F, U, and stuff like that. We can take the result of this and we can unname it, and that will kind of get rid of the names. And so now we have just this character vector here. So this is a useful thing to apply with character subset. You can kind of take some kind of, you know, abbreviation things and turn them into the kind of the full length names. Okay. So that's looking at vectors. Let's take a look at some lists. Okay. So lists work similarly, okay? as far as subsetting an atomic vector, except with lists, you also have this option to do a double square bracket, okay? So a single square bracket, when you subset a list with a single square bracket, what it's gonna return is always gonna return a list. If you wanna get the thing out of the list, right? So the list stores different stuff. If you want the thing that's actually stored inside the list, you have to use a double square bracket or sometimes a $ if there's a name, okay? So, so double square bracket and the $ are similar to this, except they're only going to return a single value and it's going to pull the piece out of the list, okay? And so one way to think of this is you can think of list X as a train with different cars, a train of cars. Each car carries objects. And so X double square bracket 5 is going to be the object inside train car 5. Okay. Whereas X single square bracket 4 through 6 is going to be the train with cars 4, 5, and 6. Okay. So single square bracket will be the train cars themselves, and you can have multiple train cars. If you have a double square bracket, it's going to be the contents of whichever kind of train car it is. Okay, so that's kind of the idea here. So here I'm going to create a list. List A. A is a list of length 2. Element X is the vector 1 through 4. Element Y is the vector 9 through 6, 9, 8, 7, 6. Okay, so this is, here's my list. So if I ask for a double square bracket 1, that's going to give me the contents. What is inside the first element of the list? That's going to be this atomic vector values 1 through 4. Okay. What is a double square bracket Y? What is the contents inside train car Y or the element Y? And that's going to be an atomic vector with the element with the atomic vector 9876. Okay. If here I'm using single square bracket, okay, single square bracket, I want train car Y, train car X, train car X, okay? And so now I have basically a list of length 3 where I've got list element Y, list element X, and a duplicate of list element X, okay? If you try to use double square brackets with a vector of multiple things, it's not going to work. Okay, you can't ask for more than one element. You can't ask for the elements outside of multiple kind of train cars. We actually end up getting something called a subscript out of bounds because it's doing something called recursive subsetting. Okay, so this says look inside element Y, and inside element Y find element X. Okay, so what's actually happening here? The previous slide where I had this, a double square bracket YX is saying a double square bracket Y double square bracket X. And that's only going to work if A is a list with element Y and Y itself is a list, has an element inside called X, right? So here I can create, this is like a train inside a train or a list inside a list, okay? So here A is a list. Okay, so question said, why did YXX work on the previous slide? The reason why is because this is single square bracket, okay? Single square bracket versus double square bracket, all right? So single square bracket, no problem. You can give YXX, YX, no problem. When you're doing double square bracket, it gets trickier, okay? So here I've got A is a list with X and Y, and inside Y, I've got elements X and Z, all right? So A double square bracket Y double square bracket X says go into A, find element Y, and inside Y, find element X. And then it says, there's a character A, right? And then you can also just do a YX, right? This is a side note. If I put a side note on something, I won't test you on that. Okay, but here's a different example, okay? Oh, geez. Okay, we've got a list ABC, a list of length 3. A is a vector 1, 2, 3. B is a vector true, true, false. C is a vector character A. Okay. And so we can say, all right, give me single square bracket 1. This is going to give you the list with element A, right? And it's a list. It's a list. D double square bracket 1 gives you the contents of list A, which is this vector 1, 2, 3. And this is type double. Okay. So notice, this is very important. Single square bracket versus double square bracket. The list containing the first element returns the contents of the first element of the list. Here is a list, no names here. I've got elements, vector 1 through 8, character vectors, character ABCD, a vector 5, 4, 3, 2, 1. Okay. If I want this L single square bracket 1, this is a list. This is the entire list element, and we know it's a list because it precedes it with a double square bracket. Okay. L1 double square bracket, this is a vector. Okay. There's no double square bracket here. And this is just the contents of basically that first train car. So what is this? Okay. Why do we get all of this? Okay, L1 single square bracket 1 is basically this thing. And we're asking, what is the second element of this? Okay, basically, there's no second element. What's here? This thing is basically a train car. First train car. What's the second train car in a length 1 train? There's nothing. Okay. Here, this says, okay, what's inside this first train car? Inside the first train car is this vector 1, 2, 3, 4. And we're asking, what is the second element of that vector 1, 2, 3, 4? The second element is 2. Okay. This thing is recursive subsetting and is equivalent to saying, okay, what's inside the first train car? Okay, that's that vector 1, 2, 3, 4. What's inside the second element of that vector 1, 2, 3, 4, 5, or whatever? And that's the number 2. So this will extract that as well. Play around with this. I'm throwing a lot of stuff at you guys. Play around with this. I think you will learn a little bit how this makes sense. Okay. Okay. So here I've got a list inside a list, a train inside a train, right? So here I've got the outer list, L2 is a list, okay? And inside L2, I put in list 1, L1 being this list of 3, okay? So here I've got a list of 3. The first thing itself is list 1, and then I've got this numeric vector and this character vector. All right, so how do I call things, right? So if I ask, what is the first element in L2? The first element in L2 is this entire list of length 3, right? And this is how it gets written. The first element in list 2 is a list, then where the first element within that list is this vector 1 through 8. The second element within that list, first list, is ABCD. The third element within that first element, the first list, is 5, 4, 3, 2, 1. Okay, so this is the notation that it uses for the thing. Okay, if I put in the structure of this, what is the structure of this? It's a list of 1, and within, so this is inside that first train car. What's inside there? There's basically a train inside the train. It's a train of length 3, and that's inside that first train car list of inside there. Whereas if I did this double square bracket, now it says, okay, so the first L2 is a train of length 3. Inside that first train car is I have a train. And so here I'm doing double square bracket. So we're saying what's inside that first train car? Inside that first train car is a train of length 3. And so now this is just a list. This is a list of length 3. So back here, the structure with the single square bracket was a list of 1, with the first element being a list of 3. The structure of this is just the list of 3. Flip through these slides, try creating a nested list inside of a list and play around with this, all right? It's one thing to see it in the notes. It's one thing to kind of create it yourself. And as you play around with this, see if you can figure out how to subset to get out, the element 30. How do I subset to get out the element 2 or the element C or things like that, okay? Okay, I'm going to kind of skip through this. As you go through the notes, and it says pay attention to the differences. See if you can understand, when do you see these double square brackets versus when do you see the single square brackets and things like that, okay? But I'm going to kind of flip through some of these things, all right? double square brackets on atomic vectors, these kind of just show you different things that happen versus, single square brackets and double square brackets. And I've got kind of comments explaining all of this stuff, okay? There's a few things that kind of make a difference, okay? If you do single square brackets on a list, so L1 is a train or a list of length 3, and if you say, give me the fourth element on this train of length 3, you get back a list containing null, okay? You get a list containing null. But if you use double square bracket, you're going to get this error that says subscript out of bounds, okay? And this is a common thing. So one thing that I want you to learn in this class is how to read your error messages, because a lot of times you get an error message in R and you just give up, okay? But actually there's useful information in those error messages that will help you figure out what happened, okay? And if you encounter something like subscript out of bounds, it means you're trying to subset on something that doesn't exist, right? So here we're saying, give me the contents of that fourth train car, right? We're saying double square bracket 4. All right, what's inside there? Well, that doesn't exist. The fourth train car doesn't exist. There's nothing in there, okay? If you give it a null object inside here, and so sometimes you think, well, when am I ever going to do this? Well, sometimes you write a function, and during the function, the result of some calculation ends up being null or missing or something, and you try to subset on this, okay? You're going to end up getting either a empty list, or if you try to do double square bracket, you're going to get an error, right? Attempt to select less than one element in the list. So these are some of the errors that you might encounter. Okay, the last few slides are all about subsetting matrices and subsetting data frames, okay? As far as subsetting a matrix, most common method is you're going to give it kind of which row you want and which columns you want, okay? But you can also subset as if it were an atomic vector by using a single vector. And you can also subset using a matrix, which is a little bit strange, but I'll show you. All right, and then we'll probably run out of time. Okay, so here's a matrix, 1 through 9, 3 rows, 3 columns A, B, C, okay? So I could say, give me back, so you use single square brackets, and there's a comma, and this will correspond to the rows, and this will correspond to the columns. So this says, give me rows 1 and 2, and I've got nothing, and again, nothing does all. So this gives, give me rows 1 and 2 and all columns. And so I get row 1, row 2, and all columns. Here I'm using a logical vector of trues and falses. So this says row 1 true, row 2 false, row 3 true. Give me column B and column A. Okay, so here we're getting column B and column A. This says give me no rows and everything but the second column, -2. So this gives me columns A and C, but then there's 0 rows returned, okay? So this is how you can do that. You can take, if you subset a vector, it will automatically try to simplify it if it can, okay? So the A is a matrix, it's 3 by 3, but then if you just say, give me the first row, okay? The first row becomes, this is a vector. This is no longer, this is not a matrix of 1 row and 3 columns. This is a length 3 vector, okay? This is, so R will simplify. It says, oh, you just asked for the first row. That's just a vector. It's not a 1 by 3 matrix. It's just a length 3 vector. If you want to preserve it, let me skip ahead. I guess I left it off. Okay. There's a way you can do it. You can say drop equals false, and it will preserve it to be a 1 by 3 matrix. I guess I didn't put it in the slides today. All right, another way you can subset, right? So you, again, a matrix is really just an atomic vector with a dimension attribute, right? So here I'm going to take the letters 1 through 25, put them into a matrix, and you can say I want the 8th element. So 1, 2, 3, 4, 5, 6, 7, 8 is H, and the 9th element, which is I. 8 and 9 will give you H and I. So you can say, so you can just give it a single vector, no comma, and it will give you the elements there, okay? And then lastly, you can give it a matrix to subset, and this will kind of give you the coordinates of the things here, right? So here I'm going to give it a matrix, and I want element row 1, column 5. Row 1, column 5 is U. Row 3, column 1 is C. Row 2, column 3 is L, and stuff like that. And so you can provide it a matrix, and you can basically a matrix of coordinates. So there's a few ways you can subset a matrix, right? So if you want to get out the U and the C and the L and the A, you can give it kind of, I want this row in this column, this row in this column, things like that. Okay, this is if you have an array, here's some stuff, just kind of read through that. Okay, and lastly, I've got subsetting data frames. I'm going to let you guys read these notes on your own. There's 20 pages or so. I don't think it's too hard. Basically, a data frame is stored as a list, so you can subset it like a list, but it also has a two-dimensional structure, much like a matrix, so you can subset like a matrix. Okay, so you can subset using single square brackets, or you can use, you can put in a comma there, and it'll be selecting like a matrix and things like that. Okay, so go ahead and read through those slides on your own time to finish out this section on subsetting here. Okay, let me give you your last view quiz answer for the day. Last view quiz answer is the letter D. The letter D as in dog. D as in dog is your last view quiz answer. Okay, and again, make sure you take your quiz. I would say take it now. Okay, just put in the answers there. But if you don't do it now, make sure you take it before our next meeting session. All right, I'm looking forward to a good class with you guys. The first homework assignment has been posted. You can go ahead and start taking a look at that. Please take the time to kind of review the remaining lecture notes. I think they're good enough for you to kind of get through on your own there. Okay, looking forward to it. Have a good evening, and we'll see you guys on Wednesday.